Assalamualaikum and hi. We are from group 6. We'll present about our assignment 1 or which is a map projection. Our group is Nurjana Shakiri binti Muhammad Safawi, that is me, Nurhanan Hamiza binti Zuri and Nur Husnina Shaza binti Rizwan. So I will pass the next presentation to Nur Husnina.
We will present about geographic coordinate, planimetric coordinates, datum, map projection, coordinate system, WGS 84, Malayan Revised Triangulation, RSO, and Cassini-Solner.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nuhusina Shahza binti Izwai. I will explain about geographic coordinate, planimetric coordinate, and also datum. Okay, a geographic coordinate system is a system that uses a three-dimensional spherical surface to determine locations on the Earth. Any location on the Earth can be referenced by a point with longitude and latitude coordinate. Any location on Earth can be referenced by a point with longitude and latitude coordinates. The geographic coordinate system is appropriate for global data sets and applications, such as satellite imagery repositories. Next, the lines that run east and west each have a constant latitude value and are called parallel. They are equidistant and parallel to one another and form concentric circles around the Earth. And the line that run north and south each have a constant longitude value and are called meridian. They form circles of the same size around the Earth and intersect of the poles. The prime meridian is the line of longitude that defines the origin 0 degrees for longitude coordinate. Next is planimetric coordinate. Planimetrics is the study of plane measurements including angle, distance and areas. Planimetric elements in geography are those features that are independent of elevations such as a road, building, footprint and river. They are represented on two-dimensional maps as they are seen from the air or in aerial photography. These features are often digitized from auto-rectified aerial photography into data layers that can be used in analysis and cartographic outputs. Lastly is datum. A datum is a plane, a straight line, or a point that is used as a reference when processing a material or measuring the dimension of a target. A geodetic datum is a reference from which spatial measurements are made. In surveying and geodesy, a datum is a set of reference points on the Earth's surface against which position measurements are made, and an associated model of the shape of the Earth to define a geographic coordinate system. Next, in engineering and drafting, a datum is a reference point, surface, or axis on an object against which measurements are made. Then, horizontal datum are used for describing a point on the Earth's surface in latitude and longitude or another coordinate system. Vertical datum measure elevations or depth. Horizontal datum are a series of data points on the surface of the Earth that are used to measure the position of oneself on the Earth's surface. We use it to measure north and south latitude and to measure east and west longitude. A vertical datum is used for measuring the elevations of points on the Earth's surface. They are used as a reference for specifying heights. Vertical datum are either tidal, based on sea levels, or geodetic, based on the same ellipsoid models of the Earth used for computing horizontal datum. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhana Mizah. I will continue about my map projection. A map projection is one of many methods used to represent the three-dimensional surface of the Earth and other round body on a 2D plane in cartography, which is map making. This process is typically but not necessary. A map projection is a mathematical formula used to transfer all part of the curved surface of the Earth into the flat surface of a map. The process of flattening on the Earth causes distortions in one or more of the following spatial properties, which is distance, area, shape, and direction. No projection can preserve all these properties. As a result, all flat maps are distorted and to some degrees. Um, we can choose from many different map projection. Each is distinguished by its suitability for representing a particular portion and amount of the Earth's surface, and its by ability to preserve distance, area, shape, or direction. The categories of map projection is equal area, conformal, equidistance, and azimuthal. Equal area is projection preserve area. Many thematic maps use an equal area projection. Conformal is projection preserve shape and are useful for navigational charts and weather maps. Equidistance projection preserves distance, but no projection can be preserve distance from all points to all other points. Azimuth projection can preserve direction from one point to other point. This quality can be combined with equal area, conformal and equidistance projection, as in the Lambert equal area azimuth and the azimuthal equidistant projection. Other projection minimize overall distortion but don't preserve any of the four spatial properties of area, shape, distance, and direction. Next is coordinate system. In geometry, a coordinate system is a system that uses one or more number or coordinate to uniquely determine the position of the points or other geometric elements on a manifold such as Euclidean space. The order of coordinate is significant, and they are sometimes identified by their position in an order to tuple and sometimes by a letter as in the x coordinate. The coordinates are taken to be real numbers in elementary mathematicals, but may be complex number or element of a more abstract system such as a commutative ring. The use of a coordinate system allows problem in geometry to be translated into problems about numbers and vice versa. This is the common coordinate system. The first is number line. The simplest number line is the simplest example of a coordinate system. Is identification of point on a line with real numbers using the number line. In this system, an arbitrary point O, the origin, is chosen on a given line. The coordinate of the point P is defined as the sign distance from O to P, where the sign distance is the distance taken as positive or negative depending on which side of the line P lies. Each point is given a unique coordinate and each real number is the coordinate of a unique point. Next is Cartesian coordinate system. The prototypical example of a coordinate system is the Cartesian coordinate system. In the plane, two perpendicular lines are chosen, and the coordinate of a point are taken to be sign distance to line. In 3D, three mutually orthogonal planes are chosen and the three coordinates of a point are assigned. distance to each of the plane. The next is polar coordinate. Polar coordinate is other common coordinate system for the plane is the polar coordinate system. A point is chosen as the pole and a ray from this point is taken as a polar axis. Next is cylindrical and spherical coordinate system. There are two common methods for extending the polar coordinate system to 3D. In the cylindrical coordinate system, a z coordinate with the same meaning as a Cartesian coordinate is added to the r, and polar coordinate is giving a triple. The next is homogeneous coordinate system. A point in a plane may be represented in a homogeneous coordinate system by a triple xyz, where x and z and y or z are the Cartesian coordinate of the point. This introduces an extra coordinate since only two are needed to specify a point on the plane, but the system is useful in that it represents any point on a projective plane without the use of infinity. WGS-84. WGS-84 is an Earth-centered, Earth-fixed terrestrial reference system main geodetic datum. WGS-84 is based on a consistent set of constants and model parameters that describe the Earth size, shape, gravity, and geomagnetic fields. The type is an ellipsoid, a horizontal datum, a vertical datum, and a coordinate system. An ellipsoid is the shape of our Earth is not perfectly spherical. So, when we try to approximate the shape of our Earth, we need to have a better model. Such a model is the ellipsoid, and an example is the WGS-84 ellipsoid, which has certain defined radius at the equator and a flattening at the top. Next is a horizontal datum. Uh, when the position of the ellipsoid on a certain location with respect to the Earth on the so-called anchor point, so set a horizontal datum. The horizontal datum is ellipsoid plus anchor point. For example, the WGS-84 ellipsoid with its anchor point is the WGS-84 horizontal datum. The anchor point of the WGS-84 horizontal datum is known to about 2 cm. Because the ellipsoid is now set with respect to the Earth, we will able to determine the geographic location. Next is a vertical datum. Vertical datum is when we determine the elevation of our position. So we can measure the elevation with respect to the WGS-84 ellipsoid. The last one is a coordinate system. A coordinate system is WGS-84 can also be one type of geographic coordinate system. The geographic coordinate system is horizontal datum plus prime meridian and plus angular unit.
Assalamualaikum. My name is Jana Shakirin. So I will continue the representation about the Malayan revised triangulation. Malayan revised triangulation is a Malayan coordinate reference system revised triangulation with Bukit Kertau as the point of the origin and has been used for cadastral mapping and survey activity since 1948 in Peninsular Malaysia. MRT-68 network consists of 77 geodetics, 240 primaries, 837 secondary, and 51 tertiary stations. It is based on conventional observation with many of the triangulation points dated as far as back as 1885. The MRT-68 has been adopted as a result of the recomputations of the earlier network together with the primary or Repsol triangulation carried out between 1930 and 1960. Uh, In this table shows that the difference between a projection name of Malaysian RSO and a Borneo RSO. Malaysian RSO is in Peninsular Malaysia while Borneo RSO in Sabah and Sarawak. And the datum for Peninsular Malaysia is at Kertau and Sabah and Sarawak is at Timbalai. And the origin of projection for Peninsular Malaysia is 4 degree northing and 102 degree 15 minutes for easting. And same goes to Sabah and Sarawak origin of projection, 4 degree northing and 115 degree easting. Next we go to RSO, which is standard form, a short form for rectified skew automorphic projection. It is also known as a Haughton projection, which is the same version as oblique Mercator projection derivation. The critical is an oblique cylindric projection. In a general, the meridian and a parallel are projected as a complex curve. Only two meridians exactly 180 degree apart can be projected as straight line. Crossing the poles, both poles are presented as a point inside the projection outline. And the distortion for RSO is a conformal map projection. It does not maintain a true direction, but angles and shape are maintained at infinitesimal scale. Distance are accurate along the central line if the scale factor is 1.0. Okay. The usage of the rectified skew automorphic projection is appropriate for mapping a large scale or small area with oblique orientation and do not follow a north-south or east-west predominant extent. So the uses and application is used for the national projection of Malaysia and Brunei. However, there are still a limitation because it is used for those area of Brunei and Malaysia only, and it's not a global projection. We go to Cassini solder. Cassini solder is analogous to the equirectangular projection in the same way transverse Mercator is to the Mercator projection. There are 9 state origin used in the coordinate projection in the cadastral system in Peninsular Malaysia. Uh, this is the projection properties, which is it is a cylindrical, neither equal area nor conformal, central meridian, each meridian 90 degrees from central meridian, and equator are straight lines, and other meridians are parallel, are complex curve, and direction is generally distorted. This is the distortion of the projection of Cassini-Solner. And the limitation is the extent on a spheroid is limited. Spheroid is limited to 5 degrees to either side of the central meridian. Beyond that range, data projected to Cassini-Solder may not project back to the same position. So that's all from me. Thank you.